But you should have got that by now. So could you join it there, please? Okay, so you're joining there now. Let me just see. Yep, could you join up there, please? All right. So, all right. So, God bless you. So, now we have here squirrels and weight in squirrel. So, this is instead of using anonymous in the class, we're using a lambda. All right. Now, so that means it's implementing the compare method of the comparator interface. Okay, so it takes two squirrels. Okay, IMAG. Okay, so it's taking two squirrels and it's returning an int. Okay, now, so what I've done now, as weight is an int, okay, I can't use, for instance, this guy s1 dot get weight dot compare to s2 dot get weight. Okay, so I can't use the compare to method of the integer class because these guys are ints. All right, now you could create curly brackets here, and you could create two variables called one of them weight, and it would be an integer, and it would get you that weight. I could call another one integer weight 2, and it'd be that one, and you could use the compare to method. This is just an alternative to using the compare to method when it comes to integers, or it comes to numbers, any number, right? Now, so explain what's going on here. So this is the compare method, okay? And it's returning an int, and it's taking in two squirrels, s1 and s2, okay? So it has to return an int. Now, weight is an int. So s1 dot weight is going to be a number. I'm going to say it's number 1. s2 dot weight, I'm going to say it's a number, it's going to be 4. All right? So we can see the weight of the first squirrel is less than the weight of the second squirrel. Yes? Yeah? So those two squirrels, so S1 is going to come before S2. Yes? Okay, so we can know that by looking at it, but the machine doesn't. The machine is stupid, right? So what we do here is following. Okay, we go 1 minus 4 gives us, what does it give us? 1 minus 4 gives us what? Minus 3. Okay, so now the number doesn't matter. What does matter is that it's a minus number. Okay, if it's a minus number, what that means is the first one stays where it is. So the first one comes before this guy. Okay, so S1 comes before S2. Okay, that's what that means. So when it's minus, it means that this guy here goes to the start, this guy here goes to the end. All right. If we do it the other way around, so if we change them around, okay, and let's say that S1 has a weight of 4 and S2 has a weight of 1. We get 4 minus 1 because that's the sum I've done here. S1, so 4 minus 1 will give us 3. Now when it's a plus number, that means that that weight is greater than that weight. So they swap places. So S1 goes here and S2 goes here. All right. Now if they're the same, they're not going to be sorted, basically. Okay. If they both are the same, so let's say 4 minus 4, which will give us 0, they're not going to be then sorted. All right. Do we understand that so far? Yeah. All right. So comparator squirtle by weight. So if you're the first one minus the second one, if you get a minus number, the first one comes before the second one. Okay. If you get a plus number, the second one comes before the first one. Yes? So here, if S1 weight is 4, sorry, 1, and S2 weight is 4, we get 1 minus 4, which is equal to minus 3, which means that S1 weight comes before S2 weight. Okay, so they're input the way they are there. All right, so if it's a minus number, that goes to the start, that goes to the end. Okay, if it's a minus number, S1 comes first, S2 comes second. Yeah, now that applies to everything. Now if it's the other way around, so if S1 weight is 4 and S2 weight is 1, we get 4 minus 1 is equal to 3, which means that S1 weight comes after S2 weight. Okay, so we swap them. You could say we swap them. All right, so that's how that works. All right, now, so if this will always sort in ascending order. Okay, this will sort in ascending order. Now, if you do it the other way around, so just to prove that this works, I'm going to, we have our squiggles up here. Do we have squiggles? Yeah, so we have our squirrels, and we're going to go collections dot sort. We're going to sort it by, so how are we going to sort? We're going to sort squiggles. And we're going to sort it by weight. So weight is 1, weight is 3, weight is 6, Okay. Oh yeah, I have to print it out. Squirrels. Now, so weight is 1, weight is 2, weight is 4, and the last one, weight is 7. Okay, so that will sort them by in weight ascending. Now, if you want to sort them in weight descending, it's very easy actually. Show you how easy it is. So I'm going to create another comparator here. Squirrel. And it's going to be by weight DESC. Okay. So equal to S1, S2. Okay, and S2, sorry. Now, so far it's the same as the other one. Okay, but instead of I do it the other way around, I go S2 dot get weight minus S1 dot get weight. Okay, to prove that this does work, so I'm going to clear the amount of squirrels in it, and I'm going to do collections.sort, and I'm going to go squirrels, and I'm going to go by weight DESC. Okay, and I print them out. Now, so we can see weight is 7, weight is 4, weight is 2, weight is 1. Okay, you're just doing it the other way around. Okay, yeah. You mean if you do S1 dot get weight minus no, S no, not really, no. Oh, you could. All right. I think here we'll just ignore that question. Okay. You possibly could, but Jesus. Okay. My head hurts just thinking of it. Okay. Now, this is just the other way around. Okay. That's all you're doing there. So it's going the opposite way. Okay. And when it's the opposite way, it means it's going to do it in descending order. This one does it in ascending. This does it in descending. This will be sorted in the opposite way, which is descending. Okay. Now, of course, again, as I keep telling you, do you need to do all the sorting on these? You could just do a sort using your SQL database. And they're sorted for you. All right. So it's debatable whether now there is something called NoSQL. Now, NoSQL is instead of using a database language, you're using a computer language to do all your data things, to do all your retrieval of data, storage of data. So you'd use something like Java. So instead of having a database language, you do all of it through Java. If you were going to use NoSQL, then you would have to know all these guys. But if you're going to use SQL, it's debatable whether you need to use these at all. Okay. but we need to load it for the example. All right. Now, so that will sort them in descending order. Okay. Now, so lambdas is what you're going to be primarily using, really, not anonymous inner classes. The reason you're not going to use anonymous inner classes is because they just look messy. That's the only reason. That's one of the main reasons you use lambdas rather than use anonymous inner class, because it looks messy. That looks a lot messier than that. Okay, it's just that's the main reason you use lambdas, is because they're neater and tidier. They're not always going to be easier to understand, by the way. Neater and tidier does not mean easier to understand. All right, so this will be sorted in the opposite way, which is descending. Okay, nothing more complex than that. Okay, now we can see in the rat class. Rat class implements comparable. All right, and we've got name, age, and weight. Okay, name, age, and weight. Now, we can use the compare to method in a lambda for a comparator. All right, so for instance here, if I do here, I'm going to say comparator. It's a comparator for a list of rats, and it's going to be called by rat lambda. Is equal to R1. Actually, if we go R1, R2, all right, and if I do this, if I go R2 dot compare to R1. Now this is an example of where you can use comparator. Right. I think this is going to work the way it should work. I just want to check one thing here. Now I do have a rat list up here, I think. So this is my rat list. Okay. So I'm going to clear my list of rats. Then I'm going to add rats to it. Okay. Now, if so there's all our rats added to our list. So I'll print them off here. So our list of rats. So I just go, so rat list. So there they are, just prints them out. Okay. Now if I sort them, it's going to use the compare to method in the rat class. Yes, does everyone understand that? Yeah. So if I sort them, it's going to sort them by name first, then age, then weight. Yes? Okay, right. So if I just do an ordinary sort on them, so I could do, go down here, collections.sort, I'm going to say rat list, and then sort it, rats, rat list. Right, so Rachel, Ray, we've got another rat called Ray, so if they're both the same name, it's going to sort them by weight. Okay, then it goes to name is Roger. Okay, so that will sort them, sorted rats in ascending order. Now, see what I've done with this guy? Is that going to be any different to that? Is that guy going to produce a different result to that guy? Bear in mind that they're using the same method. Collections.sort uses the compare to method of the rat class. Okay, here, this guy here, this comparator is using, it's also using the compare to method of the rat class. So will they return the same order of rats? Yes or no? You'd think yes, but it won't. Let's have a look at it again. Have a look at it again. Now, collections.sort, what it's doing is it's the first one. So rat1 dot compare to rat2. Look what we've done here. It's comparing the second rat to the first rat. Right? That has the effect of sorting the rats in descending order. Alright? It's the same principle as, show it to you here, that if you have the second one comparing itself against the first one, it's going to do it in descending order. Now, I'll show you what I mean. Right, so these rats are sorted in ascending order. Okay, so when you sort them in ascending order, it does by name first, and if they have the same name, it does it by weight. Alright, now I've created a comparator here, and comparator rat by rat lambda. I've rat1, rat2, and it's rat2 that's calling the compare to method on rat1. Alright, it's rat2 that's calling the compare method on rat2. Rat2 is calling the compare to method on rat1. Alright, it's not the first rat comparing itself against the second rat, it's the second rat comparing itself against the first rat. And then it goes on the list. Now, that has the effect of making your list being ordered in descending order. Just to prove it, I'm going to go collections dot sort, and we're going to sort rat list, and we're going to sort it by rat lambda. Okay, and this should be sorted rats in descending order. Okay, so it should be the opposite to the other list. All right, so I'll just make this a little bigger here. Let's see, does this work? Yep. So it goes Rachel, Ray with an age of 6, Ray with an age of 3, Ray with an age of 6, Roger with an age of 2. Then if you do them in descending order, you have Roger, Ray with an age of 6, Ray with an age of 3, Rachel with an age of Rachel. Okay, so if you can use compare to with comparator. Here's one example. You can easily reverse the order. Okay, it's the same principle as this guy up here. If you have second rat comparing itself to the first rat, it's going to do it in descending order. If you have the first rat comparing itself to the second rat, it's going to do it in ascending order. Yeah? Okay, so this is going to be here. So this is just done in descending order, which is the opposite of ascending order. Now it all depends how you write your compare to method, but that's a common way to reverse the order. Okay, that's the easiest way to reverse the order. You create a comparator and your compare to does it in ascending order. You just create a comparator where you're comparing the second one against the first one, as opposed to comparing the first one against the second one. All right. Let me just see, what does it print out? It returns nothing, so you can't print it out. Collections.sort returns void. If you print it off by rat lambda, that is going to print out an int. So let me just see. I think it will. No, it'll print out just an address, I'd say. Let me just see. Yeah, just an address. Okay. Yeah. So rat list. All right. Now, as I said, as I'm going to keep saying to you, if you don't want to do all of this shit, you set up a database and you let SQL take care of a lot of the organization for you. All right. You do a database query, it does its thing, then you pull that record from the database and then you put it into a tree set or you put it into a list or whatever. Okay. The alternative is to use these guys. Now, as I've said, the likes of Facebook, believe it or not, don't use databases. They primarily use something called NoSQL. NoSQL is doing all the stuff that you would normally do with a database through programming. All right. So if you're going to go to Facebook, this is what they use. Okay, they don't use databases. They just have everything in folders and you raw programming power to go through folders to get whatever they want. Okay, so if you were going to be using NoSQL, you'd have to know to use these things. I probably wouldn't be using Java for that, though. Most likely to be using C#, I think that's what they use. It's very similar. Okay, the principles you know here are the same principles with C#. All right. Anyway, now so you've seen comparators. You've seen how you can use comparators with using minus and pluses. Okay, using minuses and pluses. Now, we're going to create a comparator for a list of ducks. So I'm just going to delete this stuff. I'm going to type it up again. So I'll do it all one by one. So I will go here. So squirrel, just give me a minute. All right, so copy this. Bear with me a second here. Right. Fuck yeah. Right, so I go here. Now, so static void ex4. So if we look at the duck class, the duck class does not have its own compare_to method. Okay. Now, it does have a hash code. It does have a equals. It does have a toString. Okay. So we're going to have to create a comparator for the duck class. So it's going to have to be a complete comparator. Right. So previously, what we did in the rat class, which was here, we're going to now do in a comparator for the duck class. Okay, so it's going to be a separate object that's going to be used to organize lists of ducks. Okay, so what are we going to try to do here? So list of ducks that will be sorted by name, then height, then weight, then height, then by ID. Okay, duck class does not implement comparable. All right, make sure I have this here. All right, so we're going to go down here. So this is comparator. I'm going to start off, see comparator, and it's going to be duck, and I'm going to call it duck comparator is equal to new comparator duck. And I'm going to go here. Oops, missed the brackets. And I'm going to create compare to method. All right. Now, I could use the minus option. Okay. When I'm comparing the weights, I could actually, that's what I will do. Okay. Right. So what I'm going to do here is instead of using the compare to method, I'm going to say age 1 minus age 2. Yes? Okay. That's what I'm going to use here. Now, so first thing I'm going to do, I'll just leave return 0 here for a while so you won't see any errors. So the first thing we're going to do is and I'm going to call it D1 and D2. So if D1 dot equals D2, return 0. Okay, so we do have an equals method inside the duck class. Now the equals method inside the duck class, so we can see that we do have an ID. All right, so every duck that is created is unique. Okay, so we've taken care of that option. We can't have two ducks that are the same. They won't be. Why? Because we have a static int counter. Now, ideally, should really make that private as well. Okay, so it can't be accessed outside the class. If you make it private and it can't be accessed outside the class, that means that no one else, you can't accidentally go in there and change the ID of a duck to an existing duck. Or a hacker can't get access to it. Right? So if D1 equals D2, now the only way that will be true is if it's the same duck. Okay? That's the only way that can be true. So put it in here. The only option that can be true for this is if both D1 and D2 are the same duck. Okay? As every duck has a unique ID. Okay? Now, so the next one. If S1, so if D1 dot get name dot if D1 dot get name equals D2 dot get name. Now they're just ints. Okay? So if they're not the same number, I don't have to I can't put in equals there because they're not integers, they're ints. Okay? So what we're doing there, we're checking to see sorry, that's strings. Sorry, I'm talking through my arse. Hold on. Sorry. Equals D2 dot get name. Sorry. around there. So if they're not the same name, what we're going to do is we're going to go return d1 dot get name dot compare to d2 dot get name. Okay, so if they're not the same name, we will run compare to against both. Okay, if they are the same, it's going to ignore them. Okay, it's just the same. We're just doing exactly the same as we did in the rat class. See there? If name equals r.name. Instead here, we're getting the name of both ducks. Okay? So if not the same name, we will run compare against both. So two ducks, let's get the name of the first duck, name of the second duck. If they don't have the same name, then we're going to compare the two names. Okay? Andy will become before Beatrice. Zebediah will come after Adam. Okay? Now, so if the names are the same, so we're going to try it by weight. So if we say not, we have d1 dot get weight. Now this is an int. It is not, so I can't say dot equals. Okay, I can't call a method on d1 dot get weight because d1 dot get weight returns an int. Alright, and ints don't have any methods. Why? Because they're primitives. So, but I can do this. If d1 dot get weight is the same as d2 dot get weight. So, if they're not the same weight, that means we can compare the weights. So all we do in that situation then is return d1 dot get weight minus d2 dot get weight. Now I have to use get weight because the weight is a private variable. Okay, so if they're not the same weight, we're going to compare them, we're going to sort them by name. Okay, if not the same weight, we'll sort by weight. Now, if they're not the same duck, if they're not the same name, sorry, if they're not the same duck, if they are the same name, if they are the same weight, now that means they're different ducks, but they have the same name and the same weight. That means they have to have a different, if it gets that far, all right, and it's, so we've determined that they're not the same duck. We've determined that, actually I have ID as well, sorry. I'm going to sort lastly by ID, so stand corrected. I love your hats. How come we don't have any hats? You have a hat, Iggy. Huh? You wouldn't have a few hats at home for us. You, yeah. Right. So, we're going to sort by name, then by weight, then by height. So we go, if they're not the same height, if they're not the same height, then we're going to sort them by d1 dot get height minus d2 dot get height. Now, if they're different ducks, and if they have the same name, and if they have the same weight, and if they have the same height, it means our meeting finished, you prick. So I'll start it again. Won't take me 2 seconds. It won't take me 20 seconds to get it going. Jesus, this is a hard slog. Christ. So screen 2, share, invite, Gmail. Okay, so there's been sent to you again. Can join it there. Okay, so join it there, so please. Okay, all right. So if they're not the same duck, okay, so it skips that. If they're not the same name, if they're not the same weight, if they're not the same height, right? So we know that they're not the same duck, but they have the same name, weight, and height. That means the only point, if it gets to down here, the only point of difference is these guys. Dot get ID minus D2 dot get ID. Okay, so if they're the same, it's going to return 0. If they have different names, it'll sort them by names. If they have the same names, it'll go down to weights. If they have different weights, it'll sort them by weights. If they have the same weight, it'll go down to heights. If they have different weights or heights, it'll sort them by heights. If they have different heights, it'll sort them by heights. Now, if they have the same height, that means they're not the same duck, but they have the same name, same weight, and the same height. And if they're different ducks, that means they have to have different IDs. So that's why you don't need to put in the check for the ID in the last one. You just say d1.getID minus d2.getID. Also, by giving your duck a unique ID, that means that every new duck you create is going to be added to this list. Okay? Because this one here only returns 0 if it's the same duck. Okay? So it only returns 0 if it's the same duck. So I am going to create a couple of ducks down here. So I'm going to go duck D1 is equal to new duck. This is going to be duck Daffy. Okay, Daffy, he's got a weight of 12. He's got a height of 4. I don't have to put the ID. The ID is assigned automatically. I'm going to create a second duck. Duck D2 is equal to new duck. This is going to be Andy. Okay, and he's going to have a weight of 4 and a height of 7. Next one, duck D3 is going to be equal to duck. It's going to have a name of Daffy, and it's going to have a weight of 7 and a height of 4. Next one is duck D4 is going to be equal to new duck. It's going to be Daffy. It's going to be 7, and it's going to be 3 of height. The last one then is going to be duck D5 is equal to new duck. It's going to be a clone of this guy. Okay, now the order of this according to the compare to should be the following. So it does name first. So our first duck is going to be this guy. Okay, now our next duck is going to be one of the Daffies. All right, so it organizes by weight second, which is the second variable. So that means our second duck is going to be one of these Daffies. So if they've got the same weight, then it organizes them by height. So we can see that Daffy has a height of 3 and the other one has a height of 4. So that means that this one is going to be number 2. This one is going to be number 3. That means that this Daffy is going to be 4. Hold on a minute. I've done something wrong there, haven't I? Yeah, yeah. Yes. Yes, it should. No. Yeah, yeah, yes. Sorry, sorry. Start that again. So that's number 1. Okay. Now, the reason it's number 1 is because they're all the same. However, IDs are assigned automatically. So as you're creating ducks, it's going to be assigning IDs to them. So this second duck here has an ID of 2. This duck has an ID here of 5. So this end is going to come number 1. This end is going to come number 2. Okay. Number 3, it's between the 3 Daffies. Now these 2 Daffies have got the same weight, but they got different heights. So that means that this Daffy is going to come 3rd. This Daffy is going to come 4th. And this Daffy is going to come 5th. Okay. Again, by the way, this is an exam question. Obviously. Alright. It won't get much more complicated than that now for the exam question. Alright. So this looks like an exam question to me. Okay. Now, so we're going to add all of these to a list. So I'm going to list duck list is equal to new array list. Now we are so if I go to collections.sort, if I just try to sort the duck list, I get an error. Okay, because the duck class does not implement the comparable interface. So can't use this collections.sort method. Okay, so we have to use a collection.sort that takes a comparator. This guy up here, duck comparator. So I'm going to pass it collections.sort. I'm going to pass it duck list. This one is a duck comparator. Yep. Now, so we print off the duck list. Okay. I don't have this one static void ex4. Just give me a minute. Examples.ex4. And print it out. Oh, I didn't add the ducks to it. Fuck's sake. Duck list dot add all arrays dot as list for D1, D2, D3, D4, D5. Okay. Bollocks. Oh yeah. Yeah. So now end. So we can see there that ND has got an ID of 2, so that's before the duck with ND with an ID of 5. Then we see duck Daffy has got a weight of 7, and the second duck also has a weight of 7. However, the height of this Daffy is at 3, whereas the height of this Daffy is at 4. That means the last Daffy then is Daffy with. Okay? Right. Now, Now, we're going to go back to the old squirtles again. All right. So, we're going to go back to the squirtles. Or sorry, we're going to stay with the ducks. Sorry, we're going to stay with the ducks. Okay, we're going to stay with the ducks. So, I'm going to go with duck list dot clear. All right. Now, I'm sure you'll be sad to hear we're nearly finished these fuckers. Okay? No harm. All right? They're intensely boring, really. All right. So, we're nearly finished them. So, one of the last things we have to show you is these guys. Now, so I have my list of ducks. I'm going to add all these ducks to it again. All right? So it's unsorted. Right? So just to prove that it is unsorted list of ducks. So just prints them out and we get this. Okay? They'll just print off the way they're entered. All right? Now, so you've seen how you can previously use a lambda. All right? Lambdas really is what you will be using. Now, if you have more than one line in the lambda, remember that you put curly brackets around it. Remember that? Yeah? Right. Now, whereas the comparator interface has one method inside it called compare to. It also has a couple of static methods, right? That make all this shit far easier. All right. I showed you the most difficult way to do the sorting. Now I'm going to show you a lot easier way to do the sorting. All right, so let me just show you. Ah, fuck you. What's it called there? Right. So, going to create a comparator. So I'm going to call this a. I'm going to redefine this comparator up here. Okay, duck comparator. Okay, so we'll redefine our duck comparator. Right. So this is duck comparator, and it's equal to. So I'm going to say D1, D2. Okay, so this is a lambda. All right, now, but it's going to be a slightly different lambda. It's going to be a lambda with multiple lines. So that means I'm going to have a curly brackets. Okay, now, and I still put in return 0. Let's get rid of those. Why isn't that working there now? Hold on. Oh, I already have D2. What's another name for a duck? What's another name for a duck? I can't use D2 because I've already, right, just to recap, huh? I suppose. I can't use D2 in here, right, because there's no harm to this revision, all right? Why won't it accept those two? Well, so you can't use the name of a local variable as the name of a lambda, as one of the variables in a lambda. Okay, you can use the name of a variable of an object, yes, say age or something like that. But you can't use those local variables here. You have to give them some other name. They have to be effectively final. Okay, so you can't use. You can only use something that's effectively final now. So what I call them instead of D1, D2, oh, balls. TW, TW1. No, effective final means it has been assigned a value. Yeah. So D1, D2. Okay. So D1 and D2. So these are our two ducks. So what are we doing? We're redefining the duck comparator that we have up here. Okay. Now, so, and this, we're redefining our duck comparator as a lambda. Now, how do you know it's a lambda? Because I have brackets there and have that guy there. Okay. So it's an anonymous inner class, but all a lambda is a shortened version of an anonymous inner class. That's all it is. All right. So this is the same as this guy. Okay, but you don't have to say public int compare to. You don't have to say the type. Now you can say the type, but you don't have to. Okay, so it knows that D1 and D2 are ducks. Okay, as a lambda with multiple lines has to be enclosed in curly brackets. Now, so comparator interface. So put in here. Comparator interface has only one abstract method. However, it also has a number of static methods. okay, which we will use here. Now it's still a functional interface because it's still only got one abstract method inside it, but it has got, I don't know how many, it's got a good few static methods inside it. We'll see what they do in a minute. Okay, so now inside here, some of the static methods. So I'll explain some of the static methods. So there is comparing, okay, then pairing, and compare are all static methods of the comparator interface. Okay, and we can use them in place of the if statements we have in the previous version of this comparator. Okay, so in the previous comparator up here, you can see we have if statements. Right, now they're grand, but instead of using these lads, what we're going to be using is we're going to be using comparing, then comparing, and compare. Now the way these work is comparing is used to start. So comparing is used with the name. Then I use then comparing with weight. Then I use then comparing with height. Then I use then comparing with the ID. And then finally you use compare. All right? So comparing starts it off. That's the first thing you're going to use to sort your list. Okay? Then comparing is used for everything else you're going to use to compare. So comparing will be used with the name. Then comparing will be used with, and the order you want them in, weight, height, and ID. And we finish it off then with a compare. Okay? And it's easier to show than explain. So, I'm going to start it off. Now, yeah, it's not a bit like, it is exactly it. Okay? It's replacing this with method calls. That's all it's done. Okay? So, now, believe it or not, inside a comparator, you have to create another comparator. Pain in the ass, but that's what you have to do. So, I create another comparator. And it's going to be a comparator of type duck. And I'm going to call it, don't know why I called it CS. Maybe there's some reason for calling it, I don't know. Okay, so now, so comparator is the name of the interface. Now remember, when you're calling a static method of an interface, the only way to call it is the name of the interface followed, see them all there, comparing int, comparing long, comparing order, whatever. Okay, so CS comparator dot comparing. Okay, now this takes a function lambda. A function lambda is something that takes in a value and returns a value. They don't have to be the same value. Okay, a function is something that takes in a value and returns a value. They don't have to be the same type. Okay, so what we're going to do here is s dot get name. hold on a minute now. Why isn't my get name come up? Okay, why isn't? Give me a second here now. I'm wrong here. I think something wrong. Oh. Okay, something has gone wrong here now. I don't know what's gone wrong. Why isn't that working? Bear with me a second here. Okay, the autocomplete just wasn't working. All right, now, so comparator.cs, comparator.comparing. So this, you start off with what you're comparing, and that's all you have to do. It does all that for you. It sees that get name is a string. It's going to use the compare to method of get string, or it's going to use the compare to method for string. It knows that it's a string. All right. So I don't have to call a compare to method or nothing. It does it all for you. All right. Now, if that object was, let's say, a rat, it would call the compare to method of the rat class. All right. If it was a squirrel, it would call the compare to method of the squirrel class. Okay. So it knows automatically to call the compare to method of the string class. So it does it all for you. So you don't have to put in all of this shit. Okay. So this creates a comparator, and it's comparing is what starts it off. Okay. So what's the first thing we're going to compare? We're going to try and sort it by is name. If they have the same name, we go CS is equal to CS dot then comparing, and you put in the exact same thing. So this time you want to go S, and we're going to sort it by S dot get weight. Okay. So we're adding to the comparator every time. All right. So the first thing we're going to search for, or we're going to sort by is name. If they have the same name, then we're going to sort by weight. If they have the same weight, we're going to then sort by height. And finally, we're going to sort by we're going to sort by S dot get ID. So we've replaced all of this with that. Okay. No. So you have to finish it off. Okay. Now what you return then is this. You return CS dot compare D1 D2. Okay. So this tells it, right, we're going to compare it by name, weight, height in ID. Okay. It knows that it's a duck because, see, the duck, it's a duck comparator. Okay, so it knows that this S here is a duck. How do I know it's a duck? Because see it here, I defined a comparator to be a duck. Okay, so S refers to a duck. So this is your comparator done, right? And so then we go cs.compare. We compare D1 and D2 using this comparator, right? So that's a shortened version of a more complicated comparator there, right? Now, I couldn't show you that shortened version until you did all the other shit that took us 3 days to do, right? That is much easier to use, all right? So this one here, so comparing is a static method that tells that static method that defines what we will first sort by, in this case, the name of the duck. Okay, if the ducks the same name, we use this static method to say then we will. Does that come up with your screen, the 10 minutes thing? Does it as well? Does it? No. Okay. We use this time to say then we will sort by weight, then sort by height, then sort by ID. So that's our comparator. All right, that's our comparator done. So it contains all of this information. Okay, so what we do then is we go cs.compare. It's calling this comparator for two ducks. That's what's happening there. Okay, this then applies the above comparator to the two ducks that were defined as arguments. Okay, so we're going to see how does this work for our list of ducks. Okay, so this is our unsorted list of ducks. So I'm going to go collections dot sort, and we're sorting duck list, and we're using duck list with this comparator, which is called duck comparator. And then so duck list sorted by static methods of comparator interface. I'm going to say duck list. Yes, I know. Ah, shit. Yeah, cancel. I know. So it's sorted by name first, weight, height, they're all the same. So it goes to ID, ID2, 5 for ending. Then we have Daffy. Now Daffy has a name and weight of 7. The second one has a name and weight of 7. However, the first Daffy has a height of 3, the second Daffy has a height of 4. Then we have our last duck, which is Daffy, and that weighs more. Okay, so this comparator is just a shortened version of all the other comparators we've been doing up to this. All right, it. Sorry. Yeah, I did. See there? So, because I wanted to see, so I cleared it. It's an unsorted list of ducks. So there's our unsorted, and this is a duck list sorted by static methods. Oh boy. Now, any questions on that? No questions? I'm just going to do one last lambda and then we're fucking finished with these bastards. Huh? Yeah, they're painful, I know. Alright, so I want to do a different comparator. So I want to sort by weight first. What do I have for my duck? Let me just see again. So I'm going to sort by weight first, then height, then name, then ID. Okay. By the way, you don't have to put all them in. All right. What I mean by that is, if you don't want to sort by ID, then you don't have to put it in. Do you understand that? Yeah. You could choose to leave at ID. So I'm going to sort it by ID to start off with. Now, actually, if I sorted it by ID, so I'm just going to go SQR or D comparator is equal to D1, D2. Should do that. Right. Now, if I did this, comparator duck cs dot cs is equal to comparator dot now. So if we're comparing ints, you say comparing int. If you're comparing doubles, you go comparing double. Okay. So it's comparing int and so I say s dot get id. Now and I'll put in this one as well. And I'll return just if I just do that. Right. What's wrong with that? Is there anything wrong with it? Is there anything wrong with that code for a start? Yes or no? What's that going to do? What's this line going to do here? It's going to sort by what? It's going to sort by ID, right? Right. So if that's the same ID, then it's going to sort by name. Is there anything wrong with that? It's impossible. Okay, it'll never get to that line. So if you're going to sort by something that's unique, you make sure that's always the last option. You don't make sure it's the first option. Why? Because it's never going to be sorted by name. All right. So you put that one. So you change them around. So it's start off. So comparator dot comparing. Now, if you want to compare a double, now that can be a primitive double or a wrapper double, use comparing double. If you're going to use an int or an integer, you can use comparing int. Okay, comparing long. So comparing int can take a primitive or a wrapper. All right, I'm just going to say comparing. All right, so I'm going to say s dot get name. Okay, then comparing s dot get id. Okay, so there you're comparing by name first and then id. All right, so one of the rules of comparators are when using something. You know what now? I don't think I'm going to do another one because I am so fed up with these fuckers now. It's driving me fucking soft. If that's okay. So do you mind if I finish it now? Because I hate them fucking things. Oh shit, I didn't realise there's a few more things we have to do. We might get it finished tomorrow. Or we just might bring in a load of cake and eat it instead. Okay? So that's quite possible. Okay? So we might have finished our Java for the year. We might have. We'll see what the mood is like tomorrow morning. I'm just fed up with them now. There's only so much of this scutter you can do. I think cakes, yeah. I think definitely cakes. Now, chapter 5, chapter 6, chapter 7, chapter 8, chapter 9, they're actually fairly short chapters. So, chapter 4 is going to take a month to do as well. Just warning you. But the rest of them should get it finished in 2 months. We're fairly confident of. So, do whatever you want for the next 15-20 minutes. So, I can't do any more than these.
Actually, it's only 10 minutes.
Huh?
It's actually only 10 minutes. It's not going to go home.
Yeah, well, whatever, just stay here for the next couple of minutes and finish with this. Possibly finished with Java for the year. We'll see what the mood is like tomorrow morning. There may be cake.